All right. So I took the AWS Security Specialty Exam, got a 713 out of 1,000. The passing score is 750. Upside is I did very well for my first attempt. The downside is I did not pass my first attempt, but that means I only missed it by about 2 or 3 questions. So what I'm going to do is go over these 3 sections, these domains that I did not pass that show that I need to review. Offline, I'll go over the other ones, which I met expectations with. And so I figure if I hit at least 1 or 2 of these to meet expectations, well, definitely 1, definitely 2, I'll pass. 1, it's 50-50. All right. So we're going to go through a couple of sections. We're going to do the first one today. And then we're going to do questions, look at the answers, and then be able to solve this. All right. So let's get started. Okay. We're going to get started with security logging and monitoring. Okay. And we're going to get ready for this and give it our best shot. All right. But I'll give you an explanation of why the correct answer is the correct answer, why the incorrect answer is the incorrect answer. As per the latest security guidelines of a company, a root user login access should be intimated to the security team every time it's used. How will you create a solution for this requirement in the most efficient way? A, create an Amazon simple notification service topic and configure the users of the security team as subscribers to the topic. Create an EventBridge rule to monitor user identity root logins from the AWS management console and trigger notifications to the SNS topic when root user login activity is detected. So why? This is because EventBridge natively integrates with CloudTrail and can detect console login events where user identity.type equals root. So this provides real-time alerts with minimal delay. Okay, and we'll show you some references towards this. Okay, so you can monitor and notify on AWS root counter, root user activity. How do you do this in real time? Okay, you can do it MFA. These are best practices for security, right? Or let's try this one. There we go. This is the best one. How do I do this? CloudFormation to create an SNS topic, then create an EventBridge rule to monitor user identity root logins from the console. Okay, this is a very simple solution and natively built in. Okay, but why? All right, EventBridge natively integrates with CloudTrail and can detect console login. So there's no need for Lambda or Athena. EventBridge can publish directly to SNS. And for security purposes, real-time alerts ensure minimal delay in identifying unauthorized or risky activity. So why the other answers incorrect? Okay. CloudWatch events and Lambda function. While it's functionally possible, this is less efficient for the specific use case of root user login. CloudWatch events and EventBridge use the same API, but EventBridge is the preferred modern interface and allows direct SNS publishing without Lambda. Also, this solution detects all API activity from the root user, not just console logins, which adds noise. Okay. CloudTrail logs S3, analyze with Athena, trigger Lambda for SNS alerts. Okay. This message introduces latency and complexity. So Athena queries are not real time. There will be delays in detecting events. And it adds unnecessary costs like S3, Athena queries, and Lambda. So something simpler like EventBridge and SNS is native and can be done instantly. And then VPC Flow Logs, SQS, Lambda, SNS. Okay, VPC Flow Logs capture network traffic metadata, not identity or login events. So there's no way to detect IAM root logins using VPC Flow Logs. It's unrelated to the requirement and fails to meet the compliance objective. Okay, so remember, SNS, EventBridge, direct detection of console login from the root via EventBridge, which goes to SNS. All right. Question. A company operates a global data analytics website hosted on AWS. The website relies on CloudFront to deliver content to its customers. Recently, the company is facing new data regulation policies and is required to block inbound traffic from a specific set of countries. The company needs to find a solution to comply with the new data regulation policies while maintaining cost effectiveness of its infrastructure. How do you do this? It's A, geographic restrictions on CloudFront to deny traffic from a specific set of countries. Okay, so let's go to the supporting documentation. Okay, so how do you restrict this? You can use this geo-blocking. See this CloudFront? Okay. To do this, you have two options. Use the CloudFront geographic restrictions feature, or you could use a third-party geolocation service. All right. So geographic restrictions in CloudFront can deny traffic from a specific set of countries, or you can create an allow list. So CloudFront includes built-in geographic restrictions like geo-blocking, features to block traffic from specific countries. It's cost-effective and requires no extra services like WAF or Lambda. Even though technically WAF can do this, it's much more costly. All right. So it allows you to define either a block list or an allow list of countries based on request IP locations through geolocation. So let's see the other options. Using WAF web ACL with geo match condition, while it's technically valid, using WAF for country-based blocking is more expensive. WAF is better suited for layer 7 filtering. So that'll be stuff like SQL injection, headers, or IPs. It's not simple country-based restrictions. And CloudWatch geographic restrictions are simpler, faster, and cheaper. WAF web ACL with IP match condition. IP match conditions require you to manually maintain lists of IP ranges, which is inefficient and error prone. And IP match does not equate to geolocation unless you constantly update IP blocks by country, which is not scalable. And it's not intended for blocking by country. AWS already provides it with CloudFront. Okay. And then geolocation routing policies in CloudFront. So there's no such thing as geolocation routing policies in CloudFront. This is a concept related to Route 53. And Route 53 has geolocation routing used to route traffic to specific resources like regional endpoints, not to block or allow traffic requests. Okay, so remember, CloudFront geographic restriction has built-in geo-blocking, and it's cost-effective and simple. All right, let's see. Okay. Security team at a company needs to follow the security requirements. Monitor all traffic leaving a particular VPC. Monitor all traffic whose source is outside the VPC. The purpose of this traffic monitoring is to put in place a proper content inspection, troubleshooting, and threat monitoring solution. What option would do this? So the correct answer is A, configure a traffic mirror target for the monitoring appliance. Create a traffic mirror filter with a rule for outbound traffic to reject all packets that have a destination IP in the VPC CIDR block and accept all other outbound packets. Also, create another rule for inbound traffic to reject all packets that have a source IP in the VPC CIDR and accept all other inbound packets. Okay, so traffic mirroring. Okay, this gives you a solution that, traffic mirroring lets you replicate full network packets, including payloads, for deep content inspection, threat detection, and troubleshooting. You can configure filters like reject packets with a VPC CIDR source or destination and accept everything else, right? So you capture only traffic entering or exiting your VPC. So let's go over here and see. No, that's not the right one. Let's see. So traffic mirroring, going to VPC to copy network traffic from the Elastic network. Okay, so content inspection, threat monitoring, troubleshooting. You can configure this. Okay. Let's see. Okay, so let's see. No, it's not here. All right. So mirroring your traffic without having to manage packet forwarding, capture packets at the ENI, which cannot be disabled, and send your mirrored traffic to a security device. That's going to be it. So it'll have the intrusion detection, content inspection, which is in this guidance. All right, so why the other options are not correct. So VPC Flow Logs. Let's go back here. Okay. So VPC Flow Logs. They only capture metadata like IPs, port, packet counts, not actual packet content. So it's insufficient for inspection or threat monitoring. All right. Traffic mirroring works at the packet level. You cannot mirror flow logs to an appliance. They're logs stored externally, not live network traffic. So traffic mirror for TCP only. Let's see. Capturing only inbound TCP traffic misses UDP and outbound flows entirely. Okay, so the requirement is to monitor all traffic leaving the VPC or coming from outside, not just inbound. Okay. VPC flow logs to CloudWatch. While it's useful for higher level observability, flow logs lacks packet payload data and cannot feed appliances for deep inspection or content level filtering. All right, so remember this. It can inspect the payload. That's traffic mirroring. Does it support deep packet inspection? That's traffic mirroring. Okay. So let's see. One thing let's say is it goes for the deep packet content inspection, the packets in the deep content inspection, threat monitoring, and it requires that inbound, outbound, right? And it does the monitoring. All right, so let's go to the next question. All right, a financial services company manages this IT on AWS. The security team at the company has been tasked to monitor and report all the root user activities of the AWS account. What options should be combined as a solution so the security team can meet these requirements? B and D, so that would be use SNS as a target of the trigger that further notifies the security team. That looks like it'd be second. Set up a CloudWatch events rule that is triggered on any API call from the root user. Okay. All right. So why is this? So you set up a CloudWatch events rule that is triggered by any API call and set this up. So EventBridge, which is what that is, right, can filter CloudTrail logins, which we've already covered, in real time based on the field event name and user identity .type. You can create a rule matching the root user API events and use SNS to notify the security team. Okay. Let's see. So I think we've already gone into this to monitor. Yeah, so you can enable MFA, set the passwords. All right, so here you go. Root user logs in, triggers a Lambda, publishes a message, sends a notification. All right. All right. And then you can go here. Let's see. Okay. And so we've already covered this as well, which is another way to answer the question we've already done. All right. So EventBridge can detect root user API calls, and that's the solution, right? So if you have this set up, right? AWS Knowledge Center will confirm EventBridge that you enter an email, send a notification. This is efficient, it's real time, and it directly captures the root API calls as events and pushes alerts to the security team. Okay, so let's see. Why are the other incorrect? So Trusted Advisor. This is for recommendations, not real-time monitoring of API calls. It offers checks like MFA on root account, but cannot trigger SNS alerts based on API events. Config. Let's see, so config. So why is that incorrect? Config is designed for resource configuration auditing, not for user activity detection. It's manage rule IAM root access key check only monitors whether root user has an active access key, not actual root logins or API activity. Okay, and then you have, let's say, inspector. So inspector scans for vulnerabilities, so scans EC2s for vulnerabilities, right? It doesn't monitor IAM or user activity, especially not root user activities. So why is EventBridge and SNS superior? It's event-driven, it's real-time, and it's proven by AWS own guidance and knowledge base. So it doesn't require data lakes, batch queries, or polling, and it's efficient, minimal architecture. It'll be CloudTrail, EventBridge, and then SNS. Okay, so remember these three things with this. It's real-time alert, it monitors the root logins, and it's efficient. Okay, next one. All right. A retail company has a 3-tier web application with separate subnets for web, application, and database tiers. The CTO of the company wants to monitor any malicious activity targeting the web application running on EC2 instances. You've been tasked with developing a solution to notify the security team in case the network's exposure of EC2s on specific ports violates the security policies of the company. Which AWS service would you use to build an automated notification system with minimal development effort? So B and C, that would be SNS, and inspector. Okay, so why is this correct? So inspector includes network reachability rules, right? So that automatically checks whether EC2s are accessible from external networks, right? Like the internet, a VPN, or a peered VPC. And so by evaluating security groups, NACLs, route tables, or internet gateways, inspector can have findings that can automatically be sent to an SNS to notify stakeholders. Okay, so let's see if we have some documentation. All right, so reaches the reachability inspector. So you need network support scanning tools to make this process, network reachability. All right, the inspector host rules package, checks the software configurations. And let's see if we can find this. Oops. All right, so customizing the reachability rules. If you want to find this, target a subset. You can select advanced setup, assessment targets, adding them in EC2 console. You can create the assessment target. And then you can also set up a recurring scheduled notifications to your SNS topic, right? That's it. All right. So why are the other ones incorrect? Okay. Shield. Shield is a managed DDoS protection service, not designed to scan or report on EC2 port exposure. It protects against layer 3 and 4 and some layer 7 attacks, not host level port exposure. CloudWatch alone. So CloudWatch monitors metrics and logs, but cannot detect network exposure or open ports. And then VPC Flow Logs. These capture IP traffic metadata, so source, destination, IPs, and ports. They don't analyze or alert on port exposure. So you can set up logic to parse the logs and determine policy violations, but this will require extensive custom processing. So it'll be extensively more complex than inspector's built-in functionality. Right? So how do you remember this? So inspector identifies EC2 ports exposed to external networks. It has an automated network reachability analysis, and you can send an alert with SNS target. Okay. Let's see. Oop, that was the wrong one. So you got this. Network reachability. So, so classic. This looks like it's going to upgrade. All right. And there's a user guide for inspector, probably about 150 pages. 430 pages. Wow. Okay. All right. So in summary, using inspector with the network reachability rules and SNS provides the least effort, most accurate, and automated way to detect and notify on EC2 port exposure. So it'll match the security requirements of the question. Okay. Let's go to the next one. All right. A security team at a retail company uses EventBridge to monitor S3 objects, aiming to detect public access and any other changes in S3 bucket policies or settings that result in public access. So they configure EventBridge to watch specific CloudTrail API calls like put object ACL, delete bucket policy, and put bucket policy, and use SNS for immediate email notifications. However, during development, the team finds that S3 put object ACL doesn't trigger an EventBridge event, while the other two do. CloudTrail for AWS events is enabled with a basic configuration in the relevant region. An EventBridge pattern verification is correct. The team needs a solution to ensure S3 put object ACL triggers an EventBridge event without generating false notifications. What's the appropriate solution? A, enable CloudTrail to monitor data events for read and write operations for S3 buckets. Okay, so why is this correct? Okay, so by default, CloudTrail records management events, that bucket level, not object level. Okay, so that's bucket level operations, not object level, so data events, right? So that would be the put object ACL. So to capture these object level actions like setting and objects ACL, you must explicitly enable data event logging for S3 and CloudTrail. So let's see. Let's see. Data events provides data on a resource. for the data plane, not the management plane. And you can log it for this console S3. Here's the following data events. Okay. And then let's see where it specifically says something here. Okay, so you can go to the event name, read name. You can see bucket level events on the cloud console. However, you can't view data events. Let's parse CloudTrail. If you're logging, data events includes both delete objects and delete object event. All right, so that are bucket level objects. Let's see. It won't log it. So let's see. Maybe it's on this one. So logging data events. Okay, here you go. By default, it does not. By default, trails and events do not log data events. Additional charges apply. So these are operations performed on or in a resource. Okay, so these are data plane objects. You can use advanced event selectors to create fine-grained selectors, which help you control costs. Okay, and then you can go all in here. You can dig in. All right, so for data events, so this shows the data stores and types, okay? And to record CloudTrail data events, you must explicitly add each resource types for which you want to collect activity. That's it. That's it right there. All right. Okay, so so data events provide insights into the resources, but by default, trails don't do that. So you must explicitly configure them to do so. All right, so why the other answer is incorrect, okay? So the EventBridge, change the EventBridge pattern by selecting S3. So S3, EventBridge cannot detect put object ACL unless CloudTrail is configured to emit data events. So selecting all events in EventBridge still does not capture data events unless CloudTrail logs them first. Okay, change the EventBridge pattern by selecting S3. And select all events. No, yeah, I did data events, right? So all events, okay. No, I did all events, yeah. So data events. So this won't work until CloudTrail is configured for the S3 data events. And EventBridge relies on CloudTrail. It relies on CloudTrail. It relies on CloudTrail as the event source for data event patterns. All right. So S3 events like put object ACL are considered data events, which are not logged unless explicitly configured and enabled in CloudTrail. It starts with CloudTrail. So enable CloudTrail to monitor insights events for S3. So CloudTrail Insights is for detecting anomalous behavior like sudden spikes in API calls or error rates. It's not intended for detecting specific operations like put object ACL. So CloudTrail Insights helps identify this and respond to unusual activity by detecting spikes, not data plane events. All right, so how do you remember this? So you want to enable CloudTrail data events specifically, explicitly, all right? And this will capture something like S3 put object ACL, right? And this is why it's required for object level S3 operations. All right. Okay, next question. Okay, an e-commerce company's security team needs to receive notification whenever an AWS access key has not been rotated in 30 or more days. You've been hired as an AWS certified security specialist to develop a solution that provides these notifications automatically. What solution do you recommend to address these with the least effort? Enable the AWS config access key rotated managed rule and configure the max access key age parameter to 30 days. Have AWS config apply remediation using systems manager automation document for every non-compliant resource. The automation document in turn publishes a customized message to an SNS topic. All right. Why is this? Config's automatic remediation features uses SSM automation documents. So the remediation is declared in an AWS Systems Manager automation document, which is invoked by config when a resource is found to be non-compliant. So let's get some supporting documentation here. Okay. That's the wrong one. Let's try this. Okay. All right, where is this? Okay. Let's go back up here. So you have the max attempts. Max. Okay. On a specific, enter access key rotation as a stack set. Edit max access key range. So how many days old a key can be compliant. All right. And max how denotes how frequently config evaluates the key access rotated rule. Okay. And then let's see from there. All right, so once your deployments are finished, you can find the rules, log into the accounts, and config, select the rules. And on the screen, you'll find the max access key age and time interval, and then non-compliant keys for the target account. All right, and you can do this. Click the edit to automatically remediate this. Look at the automated remediation that you've created, excuse me. And I think, let's see if there's anything here. And then, so you have different alternatives for how to get this done. Let me see. Okay, so you can modify this instead of invoking publish. So this is here, but there you go. Create the SSM auto. Okay, so here it is, right here. So with the manage automation, which publishes to SNS. Okay, you create the SNS automation document, enable the config rule, access keys rotated, and link the manage the automation document as the automatic remediation step. There it is. Okay, and then config can automatically trigger this for SSM automation to perform the remediation. Let me see if we have any other supporting documentation. Yeah, there it is. All right, so you can see here's the SSM documents right there, and how config provides this. And you can see the list of locations where this is supported, the regions where it's supported. Okay, so this is good. All right, so why the other answer is incorrect? Config with Lambda. All right, so config does not support Lambda directly as a remediation target. It only supports SSM automation documents for managed remediations. All right. Okay. EventBridge with Lambda. So config automatically evaluates rules periodically. You don't need to invoke a managed rule via EventBridge and Lambda. Where is this? Oops. And let's see, trusted advisor. So trusted advisor is read-only advisory service. It does not support automated remediation actions. It doesn't. Okay, so here's the things to remember. Okay. You go from config to SSM automation to SNS to notify. Why? It's because it's the official supported remediation and notification path. That's the basic ones. All right. All right, let's go for the next one. All right. So companies meticulously strengthened its AWS cloud security solution to detect and respond to the organization's security requirements by using Firewall Manager, Inspector, and Shield Advanced services in its AWS accounts. The company has recently added the Macy Data Security Service to discover and help protect sensitive data. The company wants to implement a solution using data from these security services that can initiate alerts if DDoS attacks happen on the company's resources. Which solution will implement this requirement? Answer is A. So let's say create a CloudWatch alarm that monitors Shield Advanced CloudWatch metrics for an active DDoS event. All right, why? Okay. So this, you make this. So why is this? Okay. So Shield Advanced reports metrics to CloudWatch in DDoS namespace. And the DDoS detected metric indicates whether a DDoS event is underway for a particular ORN and has a non-zero value during an event. All right. So let's see if we can get some supporting information. Okay. So you can monitor this with CloudWatch, which collects and processes raw data from WAF and Shield into real-time, near real-time, into readable, near real-time metrics. All right, you can use this. CloudWatch sends an SNS message when the alarm changes state. Okay, so that's good. All right. Oops. All right. So let's see this. So Shield presents summaries of this. So this is visibility in the DDoS events. All right. So it's fine. So DDoS. Okay, so Shield Events reports metrics to CloudWatch or a resource more frequently during DDoS events. Okay. And as a starting point, you can create an alarm for each protected resource that reports when the DDoS detection metric is non-zero. A non-zero value in this metric doesn't necessarily imply a DDoS attack is underway, but you can take a look at the resource when the metric is in this state. Okay. So why aren't the other ones correct? Why are they incorrect? So Firewall Manager doesn't record metrics. So you can't create CloudWatch alarms specifically for Firewall Manager. Inspector log scans for vulnerabilities. It can't be used for tracking an active DDoS event. Okay. And then WAF. While WAF can detect web layer attacks, it's not designed for DDoS detection and doesn't provide a definitive indicator of DDoS events. Okay. 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 So your best bet for remembering this is going to be what cannot create an alert, right? And receive that alert from that metric. So that's what's going to help you. And what's designed for it. All right, let's go to the next question. All right, a company has recently set up AWS organizations to get all of its accounts under one organization to standardize their monitoring and compliance needs of the company. The company has the following requirements. All user activities have to be logged based on the company's security needs, define alarms that respond to specific user actions, and send real-time alerts for alarms raised. Which of the following two options can be combined to create an optimal solution for the given requirements? So C and D, let's see, implement a CloudTrail trail as an organization trail, configure the trail to forward to the CloudTrail data to the Amazon CloudWatch logs log group. In CloudWatch logs, set a metric filter for any user action event the company needs to track. Create an Amazon CloudWatch alarm against the metric. When triggered, the alarm sends notification to the subscribed users through an SNS topic. That seems like it covers it. Okay, but why? So this is the recommended way to generate alerts based on CloudTrail events in real time. CloudTrail organization trails allow for centralized logging across all AWS accounts, and then metric filters can identify patterns and trigger alarms, which can send notifications to SNS. Let's get some supporting documentation, okay? All right, so you can trigger, okay, so here's the following steps. So log to monitor your trail, configure your trail to log events, send log events to CloudWatch logs, define CloudWatch log metrics filters, assign CloudWatch metrics to the metric filters, create CloudWatch alarms that are triggered according to the threshold. You can configure CloudWatch to automatically perform an action in response to an alarm. Boom. Okay, so CloudTrail organizational trail allows centralized logging across all the AWS accounts, and you can configure the trail to send logs to CloudWatch logs, enabling real-time metric filters. All right, and then in CloudWatch logs, set a metric filter for any user action. This is the standard way to generate alerts based on CloudTrail events in near real time. So the metric filters can identify patterns like console login, put object, delete bucket policy, and it can trigger alarms. And then CloudWatch alarms can send notifications via SNS. Okay. So why are the other ones incorrect? Okay. So Lambda function. So while it's technically feasible, SQS is not suited for real-time alerting. It adds delay and complexity with no notification mechanism. And then the solution requires more custom development effort, so it violates that least effort portion. Okay. And when you see optimal solution, that's basically saying least effort. Okay. Implement CloudTrail as an organizational trail. And organizational trail and configure the trail to store logs in S3. So while storing logs in S3 is the default behavior, it's not supporting real-time analysis. So S3 lacks native alerting, and using it requires additional services like Athena or Lambda, which would simulate what CloudWatch does natively. And then using Athena to analyze logs and trigger a notification. So Athena is good for ad hoc analysis, not continuous monitoring or alerting. It requires a schedule query or Lambda integration to produce notifications, which increases complexity, which is non-optimal. Okay, so remember, CloudTrail to CloudWatch. This enables centralized logging and real-time metrics. And then CloudWatch metrics filter plus an alarm to SNS. This is a native low-effort real-time alerting. Okay. All right, let's go to the next one. All right. A security engineer has been asked to configure an interface VPC endpoint to access an Amazon API gateway private REST API that is in another AWS account. What are the key points of consideration while creating an interface endpoint in the VPC account for the given requirement? So the answer looks like C and D. So that means security groups that you can choose must have a rule that allows TCP port 443 inbound HTTPS traffic from an IP range in your VPC. And then when you activate private DNS for an interface VPC endpoint, you can no longer access API gateway public APIs from your Amazon VPC. Okay, so what does this mean? Okay, all right. So let's go over this. Okay, so API gateway private endpoints are accessed over HTTPS. Okay, that's port 443. And the VPC endpoint network interface security group must allow inbound traffic on port 443 from within the VPC, typically the calling application security group or subnet CIDR. All right, we're looking at official documentation here. And then you can see here, create an interface endpoint. I'm trying to look for. All right. And then your security groups must have a rule that allows TCP 443 inbound HTTPS traffic from an IP address in your VPC. Okay. All right. So then what's the other one? The private DNS for interface VPC endpoint. And you can no longer access API gateway. Okay. So why is this important? Okay. So enabling private DNS causes all DNS queries to the public, like execute API at whatever AWS.com, those domains to resolve to the private IP of the VPC endpoint, not the public endpoint. So this breaks access to public APIs from within the VPC and causes HTTP 403 errors if the API isn't configured correctly. All right, so let's see if we can find. Okay, let's see if we can find this. If you enable private DNS for your VPC, you won't be able to access the default endpoint for public APIs. There you go. All right, so you can invoke a private API using endpoint-specific public DNS host names. So this is where you can go into this to resolve this, but this is how we've gotten this particular answer. All right, so why are the other answers incorrect? So for better resilience, okay? Okay. So why is it not correct to select multiple subnets across multiple availability zones when creating an interface endpoint? Okay. It's not mandatory. While it's recommended for resilience, it's not required. You can create an interface endpoint with a single subnet. Boom. Okay. So, and then, all right, to connect, why is A incorrect? So VPC endpoints are for private APIs only. You cannot use a VPC endpoint, even with a private DNS, to access public APIs. These are accessed via the public internet. All right. So public APIs must be accessed over the public internet. Okay. And then the last one. You can't access your private API from an on-prem network. So why is this incorrect? You can access a private API from on-prem if you connect using AWS Direct Connect or VPN and route to the VPC endpoint. DNS must resolve to the VPC endpoint or use Route 53 private zones. Okay, so this is incorrect because to access the private API, you have to go through Direct Connect, and then the client must send requests to the VPC endpoint. So this is going for a different solution. This is answering a different question. So why is it this is correct? Remember these. For the security groups, they have to allow TCP 443. This is required for HTTPS, so secure access to the endpoint. And then enabling private DNS, this will disable the public API access. So private DNS causes traffic to resolve to private IPs. All right, let's go to the next one. Okay. Okay. A mid-sized company recently deployed Amazon Guard Duty to monitor their AWS environment for potential security threats. The security team noticed a high number of RDP brute force attacks originating from an Amazon EC2 instance and decided to take action to prevent any issues. The company's security engineer was tasked with implementing an automated solution that could block the suspicious instance until the issue could be investigated and remediated. Which of the following solutions should the security engineer implement? This is saying A, okay? Have Security Hub ingest guard duty findings and send events to Kinesis data streams via EventBridge. Configure a Lambda function to process the data stream and block traffic to and from the suspicious instance by updating the security group so that it has no inbound and outbound rules. Okay, why is this correct? This is a solution that leverages Security Hub to ingest guard duty. This uses EventBridge and it knocks out traffic, okay? So this uses guard duty to detect threats like the brute force, RDP, and then Security Hub will ingest the findings, and then EventBridge will route the findings to Kinesis. And then the Lambda function will process the stream. This is aligned with all the best practices for real-time remediation. Okay, so let's go for the brute force. Let's see. So this is, if it's the target of it, this finding severity. Okay, so go for the data source and involved in the brute force, like obtaining passwords, RDP, that's remote desktop if you're not sure. Okay, and this will indicate unauthorized access, okay? And then Security Hub. All right, so automated responses. So let's see if we can find. Huh. So this will say, oh, I don't even need the search. Okay, Security Hub will automatically send all new findings and updates to EventBridge as EventBridge events. Okay. And then how does Lambda work with this? Let's see. All right. So this will, EventBridge will consistently ingest, filter, transform, and deliver events so you can build applications quickly. That's not exactly what I was looking for, but so this is an event-driven architecture, right? So this will ingest that information, build out information to go for the Lambda integration, and then let's see if we can find that. Kinesis data streams. Jeez Louise. Okay. Okay, so you have accelerated data log feed intake and processing. So you can have producers push data to the stream, real-time metrics and reporting for simple data analysis and reporting, right? You can process data applications on metrics and then contact, oops. Okay, you can direct DAGs into another stream for downstream processing. Okay, so that's the way it would be picked up, all right? So remember, multiple data kinesis streams can consume data from a stream so that multiple actions can take place. Okay, so this does this near real time. All right, so why are the other answers incorrect? All right. All right, so let's see. Why is this incorrect? Okay. So WAF is only applicable to HTTP, HTTPS-based services like CloudFront, load balancer, API gateway, and AppSync. It cannot block RDP traffic or control access to EC2s. Okay. And why is this incorrect? So NACLs are applied at the subnet level, not individual EC2s. So blocking via NACLs could impact all resources in the subnet, which is overreaching and not precise. There you go. And then, why is this incorrect? So Kinesis data analytics is used for real-time analytics and not for infrastructure changes like updating security groups. It cannot directly interact with EC2s or modify security groups. All right, so remember, A is correct. The Security Hub, EventBridge, Kinesis, Lambda, and update to security groups. Why? This enables automated and precise remediations. Okay, Security Hub, ingest, guard duty findings, sends events, Kinesis data streams via EventBridge, and then Lambda function to process the data stream, block traffic to and from the instance. Okay. All right, here we are. A financial services company manages its IT infrastructure on AWS. The security team at the company has been tasked to monitor and report all user activity of the AWS account. What options should be combined as a solution so the security team can meet these requirements? Okay. A and E. So set up a CloudWatch events rule that's triggered on any API call from the root user, and then use SNS as a target of the trigger that can further notify the security team. So we can do this again. We'll give you a little bit more. Okay. So set up a CloudWatch event. So EventBridge rule, right? Why would you do that? So EventBridge can be configured to listen for AWS CloudTrail events where the user identity type is root and trigger a response. This is the most direct and supported way to detect and respond to root account activity. And then use SNS as a target. Why? Because SNS is commonly used to send alerts, including for email or SMS. That's a simple I think it's simple messaging service when EventBridge rules are triggered. Okay, why are the others incorrect? We've already gone over this, but let's go for this. Okay, so Trusted Advisor. So Trusted Advisor is a read-only, right? It's designed to provide best practice checks for cost optimization, security, and fault tolerance. It does not monitor CloudTrail events or API usage, especially not root user activity. All right, and then config. Okay, so config tracks resource configuration changes, not API usage or user activities. Although there's a config rule, it can only check for the existence of root access keys, not actual API usage. And then AWS Inspector. This is a vulnerability scanning tool for EC2, ECR, and Lambda, not an auditing or logging tool. It doesn't inspect API usage or CloudTrail logs. Okay. Let's go to the next one. Okay. Security team at a retail company uses EventBridge to monitor S3 objects and to detect public access and any other changes in S3 bucket policies that result in public access. They configure EventBridge to watch specific CloudTrail APIs like put object ACL, delete bucket policy, and put bucket policy using SNS for immediate email notifications. However, during development, the team finds that put object ACL doesn't trigger an EventBridge event, while the other two do. CloudTrail for AWS management events is enabled with a basic configuration in the relevant region, and EventBridge verification is correct. So the team needs a solution to ensure put object ACL triggers an EventBridge event without generating false notifications. What's the appropriate solution? C. So enable CloudTrail to monitor data events for read and write operations for S3. So you have to enable that, okay? So why is that correct, right? So the put object ACL is a data event, not a management event. And then by default, CloudTrail does not log data events unless explicitly enabled. So you must enable the data event logging on the specific S3 or all buckets to capture these actions in CloudTrail and pass them to EventBridge. All right, why are the others incorrect? So, okay, so this one, why is this incorrect? So EventBridge alone does not monitor data events from S3. Okay, EventBridge can respond to S3 only if those events are first logged in CloudTrail, right? So this is looking for part 2 without having part 1. So you must first configure CloudTrail for S3 data events, otherwise EventBridge won't receive anything, okay? All right, why is this incorrect? Why is it incorrect? Okay, so this is similar to the data events, all right? But still, all events won't include data events, just like the put object ACL, unless CloudTrail has to be logging them. So EventBridge will receive the events only from CloudTrail or other service integrations. And in this case, put object ACL must come from CloudTrail's data event stream. So you must enable that. And then why is this correct? Incorrect, excuse me. So CloudTrail Insights tracks anomalous patterns like spikes in API calls, but not specific API actions. So it doesn't log every API call like put object ACL, nor does it send those individual events to EventBridge. So what do you need to do? Enable CloudTrail management events, enable CloudTrail data events, use the EventBridge rule with CloudTrail. And that will cover what you need as far as management plane and data plane, and then be able to send notifications via EventBridge and SNS. Okay. The security engineer must ensure that all certificates imported into AWS Certificate Manager in all regions must be notified at expiry 30 days before their actual expiry via a single notification to the security administrator. The notification, along with the certificate information, must be or should be sent to the security admin and the security hub for centralized management. What steps must be taken to perform these tasks optimally? So it says is B. All right. So configure the data to expiry CloudWatch metric to schedule a batch search of expiring ACM certificates and trigger a Lambda function to send the certificates to be expired notification to an SNS topic. Lambda function can also be configured to log all the expiring certificates as findings in certificate hub and security hub. All right. So why is this correct? Okay. This is optimal because imported certificates in Certificate Manager are not automatically renewed. So you must actively monitor them. And this method uses CloudWatch metrics, which is specifically set to date to expiry, and a scheduled Lambda function to find all expiring certificates. So you can log findings in Security Hub and send an SNS notification. So let's get. Okay. So these are prereqs, your solutions overview, and you can see this is here. All right. So within this CloudWatch, all right, CloudWatch events from ACM. All right. And then invoke a Lambda function. And then the function examines the certificate. The function logs the finding in Security Hub. And then the function publishes a notification to SNS with the expiration details. SNS creates a notification to any subscriber, like a security admin. All right. There's also other alternatives that are a little more specific, but we've answered this question sufficiently. Okay. And then you can find here supported CloudWatch metrics like dates to expiry. Okay. Unit is an integer, and this is good. All right. Why are the others incorrect? Okay. So why is this incorrect? Security Hub has a built-in feature to monitor secure certificate expirations. This is incorrect. All right. Security Hub does not natively track certificate expiry across regions or consolidate notifications. It only aggregates findings. So this solution lacks the centralized alerting and does not leverage the days to expiry metric. Okay. And then let's see, why is okay, the ACM built-in certificate expiration event via EventBridge. So EventBridge fires per certificate expiration, meaning you'll get one event per certificate. This doesn't meet the requirement of a single consolidated notification for all expiring certifications. Okay. All right. And then why is D incorrect? Okay. Config's ACM certificate expiration check rule only evaluates ACM provided certificates for compliance. So it does not automatically renew or manage imported certificates. So that is the catch. All right. So why is B correct? Basically, it features the data expiry. It has a Lambda built for sending an SNS and notification to Security Hub to be aggregated. So you have a scheduler, you have a consolidation, and you have Security Hub logging. Boom. That hits all of them. All right. Next question. The company operates a global data analytics website hosted on AWS. The website relies on CloudFront to deliver content to its customers. Recently, the company is facing new data regulation policies and is required to block inbound traffic from a specific set of countries. The company needs to find a solution to comply with new data regulation policies while maintaining cost effectiveness of its infrastructure. What do you recommend? It's A. Geographic restrictions in CloudFront to deny traffic from a specific set of countries. So we've gone over this one. So geographic restrictions in CloudFront has geo-blocking via this, which allows you to explicitly block or allow access to or from specific countries, right? This is cost effective and built into CloudFront without acquiring any extra services. All right, so why the other one's incorrect? So B is incorrect. Why? So using WAF with ACL with a geo match is technically possible, but it's less cost effective than using CloudFront's built-in geographic restriction. WAF pricing includes costs per web ACL and per request, which adds up a lot for high traffic websites. And then, okay, why is C incorrect? So leveraging geolocation routing policies in CloudFront to deny it. So this refers to a non-existent feature in CloudFront. So geolocation routing is a Route 53 feature, not a CloudFront one. It does not deny traffic, it routes based on location. Okay, and then why is, all right, why is D incorrect? Oops. All right, this is not feasible. So, okay, using WAF ACL with IP match condition, this isn't feasible for country level blocking. You would need to maintain a detailed list of IPs, an extensive detailed list of IPs for every country, which is impractical, unscalable, and error prone. Okay? So in summary, geo restrictions in CloudFront is the answer because it's built in, it's cost effective, and it's country level. Okay, and then see the next one. Okay, security team at a company needs to follow the security requirements below. Monitor all traffic leaving a particular VPC. Monitor all traffic whose source is outside of the VPC. The purpose of this traffic monitoring is to put in place a proper content inspection, troubleshooting, and threat monitoring solution. Which option represents the best solution given the requirement? So the answer is D. Now what is this? Configure a traffic mirror target for the monitoring appliance. Create a traffic mirror filter with a rule for outbound traffic to reject all packets that have a destination IP in the CIDR block and accept all other outbound packets. Also, create another rule for inbound traffic to reject all IP packets that have a source IP in the CIDR block and accept all other inbound traffic or inbound packets. Okay, so why is this correct? Okay, so VPC traffic mirroring allows packet level capture, so that's deep packet inspection, by duplicating traffic from an elastic network interface to a monitoring appliance. So this filter lets you exclude intra VPC traffic and include only one, traffic leaving the VPC, so that's outbound where the destination is outside of the VPC, or traffic entering from outside. That means traffic that's inbound where the source is outside the VPC. All right, and we went over that documentation a little bit earlier, but it never hurts to bring it back up. There's traffic mirroring, content inspection, threat monitoring, troubleshooting. Okay. Oh. All right. So why are the other options incorrect? Okay. All right. Okay, the VPC Flow Logs. Okay. VPC Flow Logs to capture detailed info about traffic going to and from. VPC Flow Logs capture metadata only, so that's source or destination IP. ports, protocol, bytes transferred, not full packets. This is useful for high-level traffic analysis, not content inspection or threat detection at the packet level. So there's no ability to reject or accept the traffic dynamically or selectively based on CIDR blocks. Okay, and then use the VPC Flow Logs to configure a traffic mirror with VPC Flow Logs as a source. Oops, sorry. So this was, why was C? Okay, so B. All right, why is that incorrect? Why is B incorrect? Okay, so VPC Flow Logs can trigger a traffic mirror with VPC Flow Logs. Okay, so VPC Flow Logs cannot be used as a source for VPC traffic mirroring. Traffic mirroring only works with Elastic Network interfaces as the sources, not with flow logs. And then why is A incorrect? B, configure traffic mirror target for the monitoring appliance. Okay, so, and then trying to create a traffic mirror filter for TCP and UDP. Oh, okay, I see this. Okay, so this approach only works for inbound TCP and UDP, but it misses outbound traffic, and it doesn't apply the necessary CIDR-based exclusions to distinguish internal versus external traffic. Okay, so D is correct. Why? It's the best traffic for external, internal traffic. It mirrors CIDR-based filtering. Boom. All right. And then next question. Okay. As for the latest security guidelines of a company, root user login access should be intimated to the security team every time it's used. How would you create a solution for this requirement in the most efficient way? The answer is D. Create an SNS topic and configure the users of the security team as the subscribers to the topic. Create an EventBridge event rule to monitor user identity root logins from the management console and trigger notifications to the SNS topic when root user login activity is detected. So why is this a correct answer? Okay, so CloudTrail records all events. All right. This includes root user logins. Right, and then EventBridge can filter these logs in real time based on events like fields like event name or user identity .type. And then you can create a rule matching the console login events and use SNS to notify the security team. Okay, so why are the incorrect options incorrect? Okay, so why is C incorrect? Create an Amazon CloudWatch rule that triggers Lambda. Okay, so well, it's technically valid. It's not optimal, right? Because it triggers on all root user API events, not just login. So this adds an unnecessary Lambda logic to just forward messages to SNS. So EventBridge can directly trigger SNS, simplifying the pipeline, right? So you have EventBridge to SNS versus CloudWatch to Lambda to SNS. Okay, and then let's see. Why is B incorrect? Let's see. Athena querying CloudTrail in S3. Okay, so this is overly complex. So using Athena to query on the schedule for real-time use, it adds latency and unnecessary complexity. It's more efficient to use EventBridge's real-time detection. And then the final one, why is it A? VPC Flow Logs, SQS, Lambda, and SNS. This is way too complex, okay? So VPC Flow Logs, all right. Gosh, this is crazy. I'm sorry. VPC Flow Logs to SQS to Lambda to SNS. Whew, that's crazy. Okay, so VPC Flow Logs capture network level traffic metadata, not user identity or login events, and it cannot detect user logins, making it invalid. And then SQS is not real time. It's a lot harder to get notifications out. Okay, so your best bet is going to be D, which is going to be EventBridge to SNS. It's efficient and it's direct. All right, so that we are done for domain 2. Okay, so there's some major confusion areas and clarifications I can go over. So for me, I mixed up when to use CloudTrail versus CloudWatch versus other services. Okay, so here's some clarification. CloudTrail is for API call logging. This is about who did what, when, and where. CloudWatch is about metrics, alarms, and log aggregation. VPC Flow Logs, this is network traffic metadata. That's IP, ports, and protocols. And then traffic mirroring is the full packet capture for deep inspection, okay? So in my context, I think of CloudTrail as my audit trail for compliance, like Git commits, CloudWatch as my monitoring dashboard, like Grafana, and VPC Flow Logs as network telemetry, all right? And so S3 security layers. I was a little confused. All right, so when do you use bucket policies versus IAM policies versus ACLs versus VPC endpoints? All right. So for cross-account access, you want to use a bucket policy, IAM policy. Within the same account, you want to use IAM policy. This is usually sufficient. Network isolation, you want to use endpoints, VPC endpoints, and bucket policy with VPC conditions. For public access prevention, use bucket policies with IP or VPC restrictions. Okay. I also had issues with key management. So KMS key policies. All right, so KMS key policies versus IAM policies. When do you use this? All right. In the same account, you can use a KMS key policy or an IAM policy. Cross account, meaning you're going from one account to another, or interacting. You use both KMS policy and IAM policy. All right. With a root user, you can be locked out by restrictive bucket key policies. You have to remember that. And sometimes that can be good if you don't want somebody to have access to it. You need to have the root user isolated. And you can use a separate IAM role. And then I kept getting this one. So for multi-part uploads, you need both the KMS generate data key and the KMS decrypt policies attached. Okay, so that's the generate data key lets you create the key to encrypt, which would later get the KMS encrypt, and KMS decrypt allows you to read the encryption. Let me see, for network security services. All right, so my confusion was when to use a application load balancer versus network load balancer versus CloudFront. Okay, so in my decision tree, if you have mutual TLS required and a server must terminate TLS, you use a network load balancer with a TCP listener. If you have mutual TLS required and an application load balancer can terminate, you can use an application load balancer with MTLS listener. For DDoS protection and for global distribution, CloudFront. For legacy TLS support, you need CloudFront because CloudFront can abstract TLS versions, right? So it goes for the older stuff. Okay, and then I had some event-driven architecture issues. So EventBridge versus CloudWatch events versus SNS versus Lambda triggers, right? So the correct flow for security events would be one, you have this one option, CloudTrail to CloudWatch logs with a metric filter to a CloudWatch alarm to SNS. Or you have a service event, then EventBridge, then you have a Lambda or SNS. Or you have guard duty to EventBridge to Lambda to SNS. Okay, so I need to know that function has that event and then the event driving the architecture, or the architecture that drives the event. All right, so going forward, I need to know the security incident response flow. And I think all of us do, right? How do you detect this? You can use guard duty, you can use CloudTrail. How do you isolate this? You can use security group on the instance level, NACLs on the subnet level. And how do you investigate this? You use forensic instances, you use EBS snapshots, you use security groups to isolate. Then how do you notify? Use EventBridge with SNS. And remember, cross-account access patterns. You can have a resource-based policy, which will allow a cross-account principal, and then an identity-based policy that allows actions on a resource. And at that point, your access is granted. So review the service integration patterns, the policy evaluations, and the why behind the services, okay? And outside of this, understand when servers are required versus optimal. So for example, Security Hub requires config. SSM, Systems Manager, this needs VPC endpoints for private instances. And in cross-region security groups, these use CIDR blocks, not security group IDs, excuse me. And then also remember limitations. So remember that WAF can't use Athena for notifications. NACLs are at the subnet level. Security groups are at the instance level. All right. And then security groups cannot reference certain things like DNS names. And then secure service control policies. These don't grant permissions, only restrict them. So taking into account all of these, get stronger on this process, and we'll see you in the next one. Thank you. Have a good day.